So what can we do? Well, what we do is that we can use a set of features which can capture the general market condition. Now, generally speaking, it will be a very large features. I advise people to look broad, incorporate as many features as possible, hundreds if possible. Okay, the more the merrier, because you don't care if they're useful or not. We have a standard method in machine learning to reduce them to a smaller set that are really useful. The notion of feature selection. We have written and talked about a lot of good feature selection technique that you can reference. If you go to our website, PredictNow.ai, you will find papers and talks on feature selection, but let's assume that's done. So use as big a group of features as possible that represent all aspects of the market that might affect your strategy return. Okay. After that, train a machine learning model based on your historical strategies return and this big data and trying to predict their return. Okay, so you are trying to predict your strategy return. You're not trying to predict the market's return. So you are trying to mimic your strategy as much as possible using this sort of big data. Okay, and part of the features, and that is the most interesting part. The part of the features are the trading parameter of the strategy. In other words, let's say you have a 10-day moving average and a 1 standard deviation entry threshold and a hedge ratio of 0.5. What are the expected returns given that day's condition? And what about a look back of 20 days? What's the expected return? Now, you might say, well, how can the machine learning model know what the strategy will produce with a 10-day look back period versus with a 5-day look back period? How could it possibly model that? Well, you can create the backtest data for it to learn, right? You can, because this is a algorithmic strategy, you can run this strategy with a different look back, 5, 10, 15 days in history and see what the actual return is. So the machine learning model can learn from that, from the specific parameter value and the market condition to predict what the strategy will look like, will return. Okay, so these are what we call control features. These are features that you can vary at will because it's a backtest, and therefore you're not at the mercy of the market. You can precisely vary them, and in order for the model to learn from the past, how it performed under different regime, right? So a table might clarify that. So for example, in this table, let me see if I can generate a little pointer here. Laser pointer, yeah. So in this table, you have the first 3 columns are what we call the control parameters, right? The GDX weight of $2 versus $1 of GLD, entry threshold of 0.2, look back of 30. And these other column might be the actual market features. That's something that you cannot control, right? And then on the second row, another sample, you will give it a different set of parameters. Maybe this time the look back is 60 instead of 30 days. But of course, the market features are the same because you are talking about a particular day, let's say. So you cannot change those market features. And so on and so forth. You can vary these 3 combination of these 3 control parameters, but you cannot vary the rest of the features because they are market features. And this table altogether form the input training data for 1 day. Of course, you will repeat this for many days, right? So this is just a table for 1 day only, or 1 bar in general. You are going to vary that, replicate that. So the data set can be quite large if you have a lot of parameters, because there's a certain combinatorial explosion going on if you have too many parameters. So hopefully your strategy doesn't have too many parameters. Otherwise, it will be hard to optimize, just like any traditional parameter optimization method.